Okay, let's go over these notes. Our learning target is I can find the inverse of a function. Your warm-up should already be done. So as you're solving for y, remember we do SAD-MEP. So you are just undoing PEMDAS. So I would add 4 to both sides, and I get x plus 4 is equal to 3y. Divide by 3 on both sides, and I get that y equals x plus 4 divided by 3. Right? So we've already kind of done stuff like this semester. Over here, if I'm looking for y alone, in order to get rid of that square root, in order to get rid of that square, I have to take the square root. So I'm going to get y equals the square root of x. Okay. All right. Moving on to the next part of our notes. Go ahead and pause the video as you go along to write these down. So a function, we denote function as f of x. You've also seen it as y equals. So a function is an equation where every input, x, has exactly one output, y. A relation, on the other hand, is where an input, x, has 2 or more outputs for y. How do we tell if a set of numbers represents a function or a relation? Well, a function, each x goes to only one y. So looking at our table right here, 1 goes to 8, 2 goes to 10, 3 goes to 31. So each x goes to only one y. So that's a function. Our next one for a relation, our x values go to 2 or more different y values. So I've kind of already highlighted the ones that go to different y values. So we have 1 goes to 8, 2 goes to 7. If we stopped right there, it would be a function. But seeing the next part on our table, 1 goes to 5, we have our x values that go to 2 different y values. So it's a relation. Our next one, how to tell if a graph represents a function or a relation. I was definitely struggling when I was typing this, I guess. So it should say a function or a relation. Added some extra letters in there. So we use the vertical line test. I know we've already talked about what the vertical line test is. We talked about this, I think, on one of the first days this semester, definitely in graphing square roots. So if it's a function, the vertical line test passes through the graph once. So what that means is you just take a vertical line through your function. If it passes through your function only once, and we see that my function it passes through my function once. A relation, the vertical line test passes through the graph 2 or more times. So if I'm looking at this one and I'm putting my vertical line test through, we pass through my function twice, the graph twice. So it's not a function, it's a relation. We pass through the graph twice, it is a relation. Moving on to inverse. Inverse, we do the opposite operation. So that's something that you guys all know. We have talked about that all year. How do you find the inverse of a function algebraically? You switch your x and y, and you solve for y. So let's work through an example of that. Oh no, my notes just, see if it reloads. Okay, we've got it recorded. So now working through this, find the inverse of the following function algebraically and graph it. So we can change this f of x to actually be a y equals 2x plus 4. And then remember we've got to switch our x and y's. So it's going to end up looking like x equals 2y plus 4. And now I just solve for y. So subtract 4 from both sides. X minus 4 equals 2y. Divide by 2 on both sides, and I get that y equals, well, x divided by 2 is just really 1/2 x. And then minus 4 divided by 2, negative 4 divided by 2 is just negative 2. If you are struggling to see how we got 1/2 x minus 2, go ahead and pause the video and raise your hand for some help. Is the inverse of function. So if we're looking at this guy to figure out if it's a function, we've got to first graph it. So when we're graphing it, we can write f of x equals 1/2 x minus 2. That's just denoting our function notation. Remember, m is my slope, so I have 1/2 slope, and my y-intercept is -2. So let's go ahead and graph this, guys. Start at -2, up 1 over 2, up 1 over 2, up 1 over 2. Can't go any further, so I go back to my starting point, and I do the opposite, down 1 over 2, down 1 over 2, down 1, whoa, down over 2. And then draw your line. So looking through here, trying to figure out if our function is, if our inverse is a function, use our vertical line test. As I'm continuing my vertical line test, I am only hitting it once each time that I'm doing my vertical line test. So my inverse is indeed